lesson 6 looks at the laws of logs. So we're looking specifically at a couple of different laws. There's a product law and a quotient law. So if we look at the product law, it says evaluate the following. Log base 2 of 16 plus log base 2 of 8. So if we were to evaluate this log base 2 of 16, how could I calculate that?
Log 16 divided by log 2.
Okay, so if I go log 16 divided by 2, what do I get? 4. And log base 2 of 8, how would I evaluate that one?
Log 8 divided by log 2, which is 3.
Okay, and 4 plus 3 is?
7.
Okay. Now if I look at the next one, it's log base 2 of 16 times 8. So how would I evaluate that? What would I do first?
16 times 8.
And what is 16 times 8?
128.
How much?
128.
And when I go log base 2 of 128,
7.
so I want you to do the same thing for B. Evaluate log base 3 of 27 plus log base 3 of 3, and then log base 3 of 27 times 3. Okay, so what's log base 3 of 27?
3.
And log base 3 of 3?
1.
So the sum ends up being 4. And 3 times, 27 times 3?
81.
And what's log base 3 of 81?
4.
4. So it says to comment on the answers from A and B. So what kind of a comment could you make? Jessica, what did you say? Let's just start with the answers. What can you tell me about the answers?
They end up being the same.
Okay. Let's start with that. Same answers. Okay. Part 2, investigating the quotient law. Do the same thing. So we've already actually calculated these out. Log base 2 of 16 from above we said was equal to 4. Log base 2 of 8 we said was equal to 3. 4 minus 3 is
1.
And then what is 16 divided by 8?
2.
2. And what is log base 2 of 2?
1.
1. Because when the base and the argument are the same, the answer is always equal to 1. Okay? So do B. And then comment on the answer. So log base 3 of 27 from above was 3. Log base 3 of 3 is 1. 3 minus 1 is 2. When I divide 27 and 3, I get 9. And log base 3 of 9 is 2. So the comment, again, it's the same answer. So this gives us the product and the quotient law. What the product law says is if I'm multiplying 2 arguments together, I can separate them and then I can find the value of each and add them together. So instead of going m times n and then finding the value of log base a of that product, I can find log base a and add it to log base n. Why would you do that? Well, because if you work with logs long enough to look at this and realize what it's asking is 2 to the power of what equals 16, you can do that calculation using mental math. 2 to the power of 4, there's my answer. 2 to the power of 3 equals 8. Whereas the product from above was 128, that one might be a little bit more complex to try to find what value 2 to the power of what equals 128. It takes a little bit more work. The quotient law goes the exact same way. It says I can take a quotient and I can separate them and I can find the difference between the two arguments. Okay? The equal sign means that this goes the other way. So if I have the sum of two logs, bases are the same, I can multiply those two arguments together. If I'm subtracting them, I can divide the two arguments. Okay? So if we look at class example number 1, it says evaluate the following using either the product law or the quotient law. So in this first one, the bases are the same. That's the first thing I want to check for. Am I adding or subtracting? So if I subtract, do I use the product law or the quotient law? Quotient. And the quotient law says that I would take the two arguments and divide them. So what's 12 divided by 3? 4. And what is log base 2 of 4? 2. Would you have been able to do that in its original form? Calculate log base 2 of 12? No, because 2 to the power of 3 is 8, 2 to the power of 4 is 16. So this value in here would have to be somewhere between 3 and 4, and it's going to be some decimal answer. The same thing with this one. But by dividing them, I now get an argument and a base that I can work with. Okay, so take a moment and see what you can do on B on your own. Okay, so what would I do with B?
You can go 9 times 8 and then divide it by 2.
Okay. And what is 9 times 8 divided by 2?
36.
And what is log base 6 of 36?
2.
2. Good. Okay, so we're just going to do more examples. It says use the law of logarithms to write the following expression as a single log. So things to remember, things like order of operations. So what's in the brackets has to happen first. So what would I do with the log base x of 2 plus the log base x of 3?
Multiply the 2 by 3 for the log base x of 6.
Okay. And then what would I do with these three expressions now? Log base x of 10 plus log base x of 75 minus log base x of 6.
Well, with the first, like the log base x of 10 and log base x of 75, can we multiply them together?
Yeah.
With the 10 and 75, get 750, and then divide it by 6.
So what is 750 divided by 6?
125.
And then part B says if x was equal to 5, what is log base 5 of 125?
3.
3. Good. Okay. Class example number 3 has something added to it that can really start to mess things up. Because if I follow my laws, what I end up having is I end up having 2 times 3 divided by 6 divided by 8. When you have those two divisions, it can tend to mess things up. Or maybe it doesn't. 2 times 3 is? 6 divided by 6 is? And then I end up with 1 divided by 8. Or 1/8. So now this becomes log base B of 1/8. And if B was equal to 2, I would I'd have log base 2 of 8, which equals what? Negative 3. Okay, I'm going to put kind of an addendum to this. Let's say instead of the numbers, if I had log base b of a plus log base b of c minus log base b of d minus log base b of e. So it's the exact same thing that we had before, only now I have variables all the way through. So if we did what we had done above, a times c divided by d divided by e, which causes a problem because I can't simplify that. I can't write it as a single log because of those two divisions. So what I could do, actually there's two ways. The first way is I could change those divisions into a multiplication. So instead of dividing by d, what can I multiply by? 1 over d. And instead of dividing by e, I could multiply by 1 over e. So that when I put this all together, a times c is on the top, and d times e is on the bottom. Now it's one single expression. This becomes log base b of ac over de. The other way that I can look at this is right in this step. I can rewrite this right here. I can isolate that out. So in isolating it out, it's like removing a negative 1, which leaves me with a positive log base d and a positive log e. And then these two get multiplied together. There's my AC. These two get multiplied together. There's my DE. And the two of them get divided. So there's a couple of ways that you could answer a question like that. You could change your divisions into a multiplication. But and that happens when you're dividing and dividing again. So if you're only dividing once, you're fine. But if you're dividing twice, you need to change something. Okay. If I look at class example number 4, the expression log base 2 of x plus log base 2 of 2x minus log base 2 of x squared minus log base 2 of y is equivalent to which of the following? So what would you do in this question? What would you do, Rachel? First of all, let's start with these two. What would I do with the log base 2 of x plus the log base 2x?
Multiply x and 2x.
And what would I get?
2x squared.
Okay. And now if I subtract the log base 2 of x squared, what would I do with these two?
Divide 2x squared by x squared.
Okay. And what do I get when I divide those together? Log base 2 of 2. What's log base 2 of 2? 1. What does that match up to?
D.
B. Okay. The last one. Determine the value of 3 times log base 2 of P minus 3 times log base 2 of Q if Q divided by P is equal to 8. What do these two terms have in common?
They have the same leading coefficient and base.
Yeah, they have the same base, and they have the same leading coefficient. Factor it out. Take the 3 out. If you take the 3 out, what would you be left with?
Three, or like log 2 of P minus log 2 of Q.
Okay. My 2 logs are being subtracted, so what log can I use?
Quotient.
Quotient. Now I get log base 2 of P divided by Q. But what do I know P divided by Q equals? 8. So instead of going P divided by 2, I can now write 8. And what is log base 2 of 8?
3.
Pardon?
3.
3. And what's 3 times 3?
9.
And there's my answer. So I'm going to give you these questions to start practicing with. 1B and D, 2A and D, 3B, E and G, and 4B. Okay, let's look at 2 log x.
Wait, never mind. This one's went higher.
If I look at 2 log x, and I rewrite it as log x plus log x, because log x plus log x would be 2 log x's. What does the product law tell me that I can do with log x plus log x? I can multiply them together. And what is x squared? Or sorry, what's x times x?
X squared.
X squared. Thank you, Anne. So what we've shown is that 2 log x can be written as log x squared. So let's suppose I have 3 log base 2 of a. So 3 of log base 2a means I can take log 2a and add it to itself 3 times. And the product law says that because my bases are the same and I'm adding them together, I can multiply those a's together. And a times a equals
A cubed.
a cubed. So if I said I have a times log base b of c, how else could I write that logarithm?
Log base b of c to the power of 8.
Correct. And that becomes our power law of logarithms, which says that if I have the argument is raised to a power, I can pull that power out in front. So it says, without using a calculator, evaluate each of the following. So if I have log base 16 to the power of 12, well, if I actually were to try to do this, and I was to try to go 16 to the power of 12, 16 raised to the power of 12, I get this ridiculously large number. Okay, so that's why we possibly wouldn't want to do that. But what I can do is I can bring that 12 out in front, and now I have 12 times log base 4 of 16. What is log base 4 of 16?
2.
2. So now I have 12 times 2, which is a lot easier than expanding it out. So if I take B, bring the 21 out in front, and I have 21 times log 10. What is log 10 equal to? 1. Because the base of this log was actually 10. So I get 21 times 1, which equals 21. Okay, so now if I look at this next one. Log base 6 of 6 to the power of n. Where does the n go? Out in front. I get n times log base 6 of 6. And what is log 6 of 6?
1.
1. And n times 1 is n. Okay, the last one, I have 6 to the power of log base 6 of n. So we're going to take the log base 6 of n, and we're going to let it be equal to v. Or sorry, not that part be equal to v. We're going to let this part be equal to v. Now what I'd like you to do is I'd like you to write that as an exponent. Or, sorry, not as an exponent. How would I bring the exponent down? What would I have to do to bring that exponent down? So if I have 2 to the power of x equals 37, what did we do to bring the x down? Jessica?
You put it into the logarithm function.
We put it in the logarithm form. So this became log base 2 of 37 equals x. So then this is going to become log base 6 of v equals log base 6 of n. So what can you tell me about v and n? Pardon? They have to equal each other. In order for these two logs to be equal to each other, v and n have to be equal. So if I replace v with n up here, what I have is that 6 to the power of log base 6 of n has to be equal to n. So these give us two log identities. These logarithm identities are not on the formula sheet, but they are useful to know. The first one being, when the base and the argument are the same, the exponent is the value. Because when I bring it out in front, I get that n. And then if I take a base and I raise it to a power or to a logarithmic power that has the same base, they kind of cancel each other out because exponents and base or logarithms are inverse operations. Okay, so the questions I want to add is 5